All right, this video focuses on rationalizing denominators with square roots. So just go ahead and pause if you could and read this slide. All right, we're going to start off with rationalizing single radicals. So what we have is 1 over the square root of 3. The rule is you cannot leave a radical in the denominator. So what we have to do is we have to rationalize it. In order for us to rationalize it, we look at the denominator, we say, oh, here's our square root of 3. So we're going to multiply both the numerator and the denominator by the square root of 3. So I'm just going to move down here. So 1 over the square root of 3 is our original problem. We're going to multiply the numerator and the denominator by the square root of 3. Now we multiply across. 1 times the square root of 3, and then square root of 3 times square root of 3 is square root of 9. Now let's see what happens. 1 square root of 3 can drop the 1, so that's still square root of 3. And then square root of 9 is a perfect. Square root of 9 is 3. So your final answer, what it does is it reduces that radical in the denominator. It's gone. So this is what we call rationalizing the denominator. Here are a couple more examples here. Part A, 15 over the square root of 6. There is a square root of 6, a radical, square root in the denominator. We need to rationalize it. So we look at the denominator, it's square root of 6. So we take the numerator and the denominator and multiply it by square root of 6. Now we multiply across. 15 times square root of 6 is 15 square roots of 6. Then the denominator, multiply across. Square root of 6 times square root of 6 is 36. Because 6 times 6 is 36. All right. Now, the denominator can be reduced again. 36 is a perfect with 6. So the square root of 36 is 6. The numerator we did not touch. Now let's see, can we do some reducing? 15 and 6 can reduce by 3. So this becomes a 5, this becomes a 2. So the final answer then is 5 square roots of 6 over 2. All right, part B, 12 over the square root of 8. We want to rationalize that. So multiply the numerator and the denominator by the square root of 8. Multiply across. 12 square roots of 8 over square root of 8 times square root of 8, 64. All right, square root of 64 is a perfect with 8. Square root of 64 is 8. Now we can leave the numerator alone, and let's see if anything reduces. Be careful. Don't reduce this square root of 8 with this 8. That's a common mistake some students make. Square root of 8 is actually a pretty small number. If you throw that in your calculator, the square root of 8 is 2.8 approximately. All right, but we can reduce these. 12 and 8 by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So 3 square roots of 8 over 2. All right, now let's look at that radical. Square root of 8. Can we do anything with this square root of 8? Yes, we can break it down. The square root of 8 can be broken down as 4 times 2. All right, do you see a perfect there? Square root of 4 is a perfect with 2. So a 2 is going to pop out. And we still have a 2 underneath, and then my denominator has not changed. All right, we got some more reducing to do. This 2 and this 2 can cancel out. 2 divided by 2 is 1. So our final answer then is 3 square roots of 2. And that's how you rationalize a denominator of a square root.